Hi and welcome. In this presentation, we will be going through how to properly send through errors when you are building out APIs in Node.js. So let's quickly have a look at our app directory. Now, our app directory has a bunch of routes associated with it. So you can see it has a bunch of middleware, first of all, and also this routes, which is this user routes, and finally, um, there should also be a routes directory over here. So when we have a look at this routes, it refers to routes-index, and we can just go over here to see what that looks at. So routes-index, and we go over here. Routes-index refers to this API-v1, and that contains two routes. One is this test route, which contains this testing, and the second one is this boom route, which contains this boom slash dot bad request. Before we get into it, you will notice there are two additional features related to async. So generally we would want to use async to be able to do async waits, which prevents callback hells, but there are some trade-offs associated with it, right? When you use this async function, how does the error propagation actually work? So if you go back to the app file over here, app.js, generally what's supposed to happen is when you throw an exception, that exception triggers this error handler. And you can see it's this express error handler, and it logs out the error. And in this case, if it's not a boom error, it's transforming it into this boom error. And we'll get into what that is exactly in a moment. And finally, it returns this status back, right? So if you throw an error, this is the method which is called, and it returns back this. But what happens is if you do have an async method, then then that error is actually lost. And I'll give you an example of that. So let me go over here and go and create another route. And in this case, we don't want the async method, so we can just do a general, straightforward test. And let me zoom in here. So when we are doing this test, in this case test, and I will just go test first. I will save this test first, and what you will see over here is, if I go all the way down to the bottom, let's move this test first. I'm going to hit enter on this, and so you can see that I have got this error back, right? I'm getting this error back, which is saying that 500 internal server error, which makes a lot of sense because if there is a error or runtime error which is associated with it, what happens is it goes back to this, it goes to the app.js file. Once it goes to the app.js file, since it's not a boom error, it transforms it into the boom error, and then it specifically logs out this payload. And just to show you what the normal error looks like in the boom error without the app/payload section associated with it, if I save this and then just refresh the screen. So this is what the full boom error looks like. Obviously, for our use case, we just are interested in this payload, and we want to keep this consistent payload regardless of our exception. So that's why we use this, and again, everything is transformed into boom error, even if it is in a boom error. Now, if it is a 500 error, which is a 500 error or some type of internal error or runtime, well, some type of uncaught internal error, it will not be a boom error. In the event that it's not a boom error, it just gets this boom bad implementation, which is a 500 method. And you'll also note when we actually get this back, let me go back to the screen. When we actually get this back, we don't actually get the message associated with that 500 error. And if you think about, and this is mostly to do with security and also potentially user experience, but mainly due to security. If you think about it, if you do have a runtime exception, you don't want to throw the details out of the runtime exception to your clients, because if they know what the exception is, they can be potential security issues related with that. So that's why this bad implementation doesn't actually display the actual message associated with the error, which in this case is testing. So in this case, what we observed was for a straightforward method, and by straightforward I mean a non-async method, if there was an error associated with it, it is giving back a 500. And we also found out that we don't necessarily care about all these other details. We only care about the payload, and that's why we're seeking this out over here. Okay, now what happens if once that method becomes an async method, right? So let me just add this here. And when that becomes an async method, and what would you think happens when this occurs, when this error occurs? Well, let's see. We can see that it's pending, and so what happens is, because this is an async method, the propagation of the error doesn't actually come through, right? The propagation of the error doesn't come through, and as a result, this stays in pending for an extended period of time until it actually times out. So let me just kill that. So to remediate that, what we do is we wrap it with this async middleware call. And this async middleware call, if we go to the utils, you can, let me just cancel that. If you go to the utils method over here, that async middleware calls is a promise. And that promise, and so you can see that it's a function which contains a request, a response, and a next. And in the event, this function, which is referring to this function over here, and this is actually missing the next value, right? So this function definition, this function definition is equivalent to the function definition over here. So what we are saying is this async middleware can accept a function, and if there is, and that function in this case, we can put into a promise, and if there is an error with that function, then we do this. And this is what allows the continuation of the, or the propagation of the actual exception back up the stack. And so we can see that if you wrap this up in a async middleware, this function in async middleware, what happens is this whole function over here becomes a promise, because we wrapping that up in a promise, right? So you get the function over here, we wrap that up in a promise, and in the case an error occurs, we catch that error, and we call the next middleware. If it's not a Boom implementation, we call it using this, and if it is a Boom implementation, we call it the next middleware. And the next middleware obviously goes through to the error handling, which is over here, which goes into here, and that sends it back out. So if it is, so this async method, async middleware method, is crucial. Without it, a typical async function error within a typical async function would not propagate all the way to the error handling, and that's why this async method is very important. And let's just check that out, right? So I'm just going to copy this over here, put that over here, and put that over here, and save. Now, when I go back and do this game, what you will see is I will get a, now I'm getting that internal error, right? So before, what was happening was this pending was just taking a really long time. It wasn't properly getting back up, but now I'm getting this internal error. Now, the final point to note here is, again, the catch-all for this is both in the async middleware. If you throw an error, or if you have a undefined error, not an undefined error, basically an error which is a runtime error, and so this is representation of a runtime error. You don't want these runtime errors to be shown up to the client. Therefore, this Boom implementation which you have in here hides that. But in other cases, the Boom implementation actually shows the relevant message in the field. And so, say for example, we're doing some client-side validation, and we can look at the Boom documentation for this. If you're doing some client-side validation, which is all 400 errors, and we want to show a unauthorized message, what we could do is, let's just, boom is already implemented. What we can do is just go throw boom dot, and let's just go unauthorized in this case, and we can send a custom message if we wanted to. Say you are not allowed, right, to use this method. And once, so let me save that and go back to our screen over here. And so what you will see here is the message will not just be a generic internal server error code, but a specific one. You are not allowed to use this method. So use it accidentally. And let's just check out what the default method is. Messages over here. Save that and unauthorized. So it's exactly the same as that. And so this shows how you can give consistent responses back from consistent error responses back from your API in the event that an error occurs. So just tracing all of that back, just in case you missed it, we have these routes which are defined in your app for your Express project. Right now, for each Express project, you have middleware, and for that middleware, if an error is thrown, you have a error handling functionality which is available, and this actually gets triggered, and it works as expected. We're using boom over here, and we are giving back a specific JSON method of the payload, right? And that works in majority. That actually works great. However, if you are using async functions in your routes, then if you do throw an error or even a boom error in your route, then that will not be propagated up to the client. Well, that error is not propagated up, and therefore that request from the client side remains in a pending status. Therefore, you need to wrap it up in this async middleware, which receives that route definition over here. Receives that route definition over here, and it triggers or propagates it back up to the error handling, but if there is an issue with this promise resolving. So that's how we propagate async route exceptions which occur through to the error handling functionality in your Express project. And also we are using boom, and specifically this line over here, to standardize what our error message looks like, or our response looks like. Thank you.